In the previous lesson, we solved multi-step inequalities and graphed them. It's basically the same thing as solving multi-step equations. But you notice in the last lesson, I don't know if you picked up on this, but all the variables were on the same side of the equal sign. That isn't always the case. So today we're going to focus on how do you solve and graph inequalities that have variables on both sides of the inequality sign. Write down your learning target, try out the 3 warm-up questions, hit play when you're ready to go. Okay, so for the 3 warm-up questions, on number 1, you got 2x on the left and 7x on the right, but you also have 15 on the right. So what I did was I took my 7x and I got it off of the left side there. So I subtracted 7x to cancel that out. So negative 5x equals 15 divided by negative 5. On number 2, you have to distribute the 4 to the p minus 1. So that becomes 4p minus 4 equals 3p plus 2. And then I just got since I have more p's on the left side, I took the 3p off of the right side, as you can see there. So I subtracted 3p. I got p minus 4 equals 2, and then add 4 to both sides. P equals 6. Last one's an inequality. You have to distribute the 5. So we get 10 minus 5b is greater than 25. I got to get the 10 off of the left side because it's like terms with 25. However, remember that minus is for the 5b, not for the 10. If I did 10 plus 10, I'd get 20, not 0. So I subtract the 10, and then I get 10 minus 10 is 0, minus 5b is negative 5b is greater than 15. Divide both sides by negative 5, and you get b is less than or equal to negative 3 because I divided by a negative. You notice up here the first step, I squared 5 to get 25. So that's the warm-up. That's going to help us as we go ahead and work on these inequalities down here. So on number 1, I have 4x is greater than or equal to 7x plus 6. So remember, the whole goal here is to get all the non-x stuff on one side, all the x stuff on the other side. So since I have some non-x stuff on the right side and nothing on the left, I'm just going to leave that over here. As some of this is just strategy, learning how to kind of attack different problems based on experience and practice. So I got to get rid of this 7x. When I do that, I have 4x minus 7x on the left. I get negative 3x is greater than or equal to 6. I'm going to divide by negative 3. And I get x is less than or equal to negative 2. This is one where you have to flip the inequality sign because you're multiplying or dividing by a negative. So the dot goes at negative 2. What kind of dot? Think to yourself. Well, this is less than or equal to, so I include negative 2 as a solution. I have negative 3 on this side, negative 1 on this side. X is less than or equal to negative 2, so I'm going to go to the left. Go ahead and right now pause the video and try number 2. When you're ready, hit resume to see if you worked it correctly. Okay, so on this one, as you can see, I've done the work here. I had more t's on the left than on the right, so I just took my negative 2t, and to make that become 0, I had to add 2t to both, because negative 2t plus 2t equals 0. So you have 7t plus 1 is less than negative 6. You could have, by the way, taken the 5t to the right side. So you could have gotten the same solution as me, taking the t's the other way. Doesn't really matter. Work it all down, you get t is less than negative 1. That's going to be an open dot. Change colors here. Open dot at negative 1. And t is less than negative 1. So I'm going to go toward the numbers that are less than negative 1. Okay, number 3. We got to do a little bit of distributing here. So I get 2k minus 6 is greater than 6 plus 3k minus 1. By the way, I'm going to do these next two, and then I'm going to have you try 5 and 6. Okay, so on this one, notice how I have 3k. Well, I've got a little bit more simplifying I can do. Okay, so you want to simplify everything you can on both sides before you start moving things around. So I can do this 6 minus 1 on the right side. So you have 2k minus 6 is greater than 5 plus 3k. Okay, and now I'm going to go ahead and, it doesn't matter, you can move the 3k's over to here or the 2k's over to here. Since I have more k's over here, I'm going to go ahead and move 2k over there. So I'll do minus 2k, and that gives me negative 6 on the left is greater than 5 plus k on the right. And then I'm going to get rid of my 5 here, so subtract 5 from both sides. And I have k is less than negative 11, aka negative 11 is greater than k. So inequality, we're going to graph it. I got negative 11, negative 12, negative 10 is on the other side. This is an open dot. And then this one, the variable's on the right, so it's always helpful to take some test points here. If I take negative 12 and plug it in, negative 11 is greater than negative 12. That works. Negative 10 does not work, so I'm going to go toward negative 12 with my graph here. And the next one, again, we want to simplify everything we can on both sides. That means that I need to get rid of these parentheses by distributing. So I have 4y minus 1 is greater than or equal to 4y plus 2. You might notice something right away. You've got 4y on this side and 4y on this side. Well, what happens when we combine those? So if I do minus 4y to get these 4y's out of here, right? That leaves 2 on the right side. If I do minus 4y over here, it gets rid of them, I have negative 1. And look what I'm left with. I'm left with negative 1 is greater, negative 4. I forgot to distribute to the 1 here. Whew, that was close. Caught my mistake. Negative 4 is greater than or equal to 2. Well, that's not true. That's false. So what that means is there is nothing. If I simplify this all the way down, that means there's nothing we could plug in for y that would actually work here. So that means no solution. There are no solutions here. The symbol for that, by the way, is called a null set. Null, N-U-L-L. Okay, empty set. So you put a 0 with a slash mark through it as the symbol for, you can either write no solution or you can put that symbol there. Go ahead, what I want you to do now is try 5 and 6 on your own. Don't get intimidated by 6. It's actually a little bit easier than you think. Try 5 and 6 and then hit resume when you're ready to look at solutions. Okay, so I did most of these, but I paused right at the end here. Okay. On number 5, you'll notice when we subtract x from both sides, I get negative 2 is less than 1, which is a little bit different than number 4, because in number 4, the statement was false at the end. In number 5, the statement is true. Think about what that would mean here. On number 5, that would mean that every number we plug in for x will work. See, if I plug in, say I plugged in 4, well, I would plug 4 here and 4 here. Well, 4 minus 2, here I'm subtracting 2 from 4. Here I'm adding 1 to 4. Obviously, subtracting is going to make it less than if I added to it. Or if I did negative, even if I did negative, I'm still subtracting from a negative, pulls me deeper negative. Here I've got a negative, but I'm adding 1 to it. So it's still bumping it up closer to 0. So that less than is still going to hold true, even if it's negative, fractions, whatever. That means that every number we plug in is going to be a solution. So this is actually infinitely many solutions. So the solutions are actually all real numbers, right? So the symbol for that is this fancy R, which is like an extra line down through it. Okay. Number 6, when you distribute the negative 1/4, because we have to simplify this part right here, right? Notice I get negative 1/4 plus negative 9/4. Now this is why I told you this problem isn't as hard as it seems. I got negative 1/4 here plus a 4th here. Well, negative a 4th plus a 4th is 0, so we're just left with negative 9/4. On the other side, I have 1 minus n. So I got to subtract 1 from both sides. It is okay to kind of come over to the side and do that as scratch work if you need to. So I just made 1 into 4/4, and then negative 9 minus 4 is negative 13/4. I stopped here, but I'm not done. Okay, so negative 13/4 is less than or equal to negative n. Well, if I have negative n, I don't want negative n, I want positive n, right? Well, negative n is like negative 1 times n. So if I want to make this positive, I've got to divide by negative 1. Well, dividing by a negative there on the left side would be positive 13/4, which is greater than now, because I divided by a negative, n. And then I want to actually, to make that easier to graph, I'm going to do 3 1/4 greater than or equal to n. And then on my number line, I can put 3 here, 3 1/4, and then 3 1/2 would be good increments there. This is a closed dot at 3 1/4. And I'm going to go, well, let's plug in some numbers and see which one works. If I plug 3 in, that'd be saying 3 1/4 is greater than 3. That's true. If I plug 3 1/2, that'd be saying 3 1/4 is greater than 3 1/2. That's not true. So I'm going to go to the left. Okay, notice I didn't graph numbers 4 or 5, because if there's no solution, there's nothing to graph. Graphing infinitely many would just be the number line itself, so it doesn't make sense to graph that one either. Let's take a look at what this looks like in a couple real life contexts. So number 7, we got a geometry example here. Number 7 says, write and solve an inequality, find the values of x for which the area of the rectangle is greater than the area of the triangle. So for this, you got to remember some formulas. Area of a rectangle is length times width, or base times height, right? And we want that to be greater than the area of the rectangle, which is 1/2 base times height. Well, the base of the rectangle is 15, and the height is x plus 3. That's greater than 1/2 times x plus 5 times 20. So I'm going to simplify everything I can here. So on the left side, I got 15x plus 45. On the right side, I can take this 1/2 and multiply it by 20. That's like the commutative property. I can take this x plus 5 and switch it around with this, because according to the associative property, 1/2 times 20, it works a little bit better. They're more compatible numbers. So that gives me 10x plus 5. And I'm just bringing 15x plus 45 along for the ride. And then I get 10x plus 50. Think about what we're finding here. We're finding values of x that make the area of the rectangle greater than the area of the triangle. So I'm going to start getting my x's together now that I've simplified everything. So I'll do minus 10x here, because there's more x's on the left side. So I have 5x plus 45 is greater than 50. Subtract 45. I'm running out of room. So I get 5x is greater than 5. And we're going to divide by 5. So x is greater than 1. So every value greater than x, or greater than 1, works for x. Okay, Trib Review charges $6.50 plus $80 per week to run an ad. And the Post-Gazette just charges $145 a week. How many weeks will the cost at the Review be less expensive than the cost at the Post-Gazette? So think about the unknown here. We're going to call it W. Notice it says, how many weeks? How many weeks can we run this ad where the Trib, where you pay the, with the Trib, you got to pay the startup cost of $6.50 and then $80 per week. So you have a large upfront cost, but then a lower cost per week. So W is number of weeks the ad is run, okay? So what we have here is we've got two options. We've got the Trib and we've got the Post-Gazette. Remember we talked about inequalities are comparisons. We want the Trib to be less expensive. That means less than. Trib is less than Post-Gazette. Could it be equal to? No, because then it wouldn't be cheaper. For the Trib, I got $6.50 plus $80 per week. Well, that's an expression. I got $6.50 plus would be plus $80 per week. That means $80 every W. So I'm going to pay $80 multiple times, $80 per week. Is less than, the Post-Gazette is $145 per week. So that's $145. $145 W. And now I've got an inequality. I just need to solve this. So subtract 80W. I end up with 650 is less than 65w, and we divide by 65, 10 is less than w. What that would mean is w is greater than 10, right? So the add would be, so the trib, so interpret this with a sentence, trib is less expensive, because that's what they want to know. When is it less expensive? After, so more than, so after 10 weeks. See, at 10 weeks, they're equal. So if I do 80 times 10, I get 800. 800 plus 650 is 1450. 145 times 10 is 1450. So at 10 weeks, they're equal. At 9 weeks, the trib is still more expensive. At 11 weeks, we're good. Okay, quick closer and then we're out. Replace the blank so the inequality is an identity. In other words, all real numbers are solutions. That's like number 5, okay? And then number 2, replace the blank so the inequality is a contradiction. So there are no solutions. So think about this, and then pause the video, and then hit resume when you're ready. So for number 1, really, the only thing I'd have to do, since I'm subtracting 2x from both of these, that means the 2x's are going to cancel. So if this is going to be true all the time, in other words, all real numbers, all I have to do is pick like a number here that's smaller than the number here. The number of the first blank has to be less than the number in the second blank. Down here, if I want it to not be true, the number in the first blank has to be more than the number in the second, because here, this is going to cancel, these are going to cancel, right? And I'd be left with 7 is less than 5, which is not a true statement. So that's inequalities, okay, with variables on both sides. So just don't forget that little wrinkle about contradictions and identities, or where there's no solutions for a contradiction, and all real numbers is the solution for identities. So go ahead and try your homework and move on to the next lesson when you are done.